and another is water splitting. So these are the two applications I'm going to teach you the various aspects of the photocatalysis and water splitting. Yesterday we have seen how to synthesize the nanoparticle. So if you recall your memory, you might know about the technique that are used for synthesizing nanomaterial. One technique which comes under top-down methods, and we have seen there are 4 techniques, but beside 4 techniques there are 10 techniques that can also called as top-down method. Due to time restriction, I just explain you the 4 techniques. So here you remember that the bulk material is bigger, and then you start from the big and end up with the small particle. In case of bottom-up, you started from the clusters, atoms, and then you ends into the nanoparticle. So these are some of the material that you can synthesize, you can prepare using the 2 approaches, top-down or bottom-up technique. So you can prepare various thin film rods, wire, quantum dots, or nanocrystals. In case of maybe biology, they can also prepare the proteins. This is the scale through which you can come to know that if you are interested in nano and micro, most of the top-down technique are prefer to synthesize those structures. And this is the last slide for yesterday's review. What we learned yesterday, we learned about ball milling, thermal evaporation, laser ablation, and sputtering. Then chemical vapor deposition, hydrothermal method, and co-precipitation method, and last was Sol-J. So these are widely used technique to synthesize the nanostructures. Now coming to today's talk about green energy, application in green energy. Today's lecture will cover 4 topics. First, what is photocatalysis? Because most of you might not well aware about the photocatalysis. Few students are doing the research in the field of photocatalysis. They might know various aspects, but most of the students, when I interact with you, I found that you are not working on the photocatalysis. So this topic will be interesting for you to know the various aspects of photocatalysis. What is photocatalysis really means? Then what kind of recent development occur in the field of photocatalysis? Then there are some examples to prepare the nanocomposite material based on metal oxide and see how they behave when they are considered for the photocatalysis application. So I will show you some of the example how these nanocomposite material, ternary nanocomposite material, binary nanocomposite material give better performance for photocatalysis. And fourth is the water splitting for hydrogen production. The title is green energy. Green energy means it should be environment friendly, sustainable. It can be used again and again. It cannot create carbon dioxide or byproduct which is harmful to the environment as well as humankind. if we find such kind of energy sources, those sources are nothing but green energy sources. You might heard about renewable source, like CNG you use for the fuel. But CNG also create CO2. So it is renewable energy, but still it has a problem of CO2. It's better than the petrol gasoline, but still it has some disadvantages. So when we look for the complete green sources, it means that it should not create any byproduct that can harmful, that can create pollution, that can cause some problem to human. So those sources are good sources for green energy application. So here, earlier we were using non-fossil, that was having bigger problem of creating CO2 and various byproduct. Then we started to use renewable energies. So renewable energy means it can be sun or some kind of gases. But when we use renewable energy, it is not complete green energy. It needs some kind of assistance of electricity or some other method support, that we cannot say it is a green energy. We can say it as a renewable energy. So in the search of green energy, the thought to find out such energy sources with the help of the sun. Sun is giving energy, and that energy can be utilized for various purposes. For example, photocatalysis, we have lots of sunlight, and those sunlight can be used for the application such as photocatalysis and hydrogen production. Then when we search for green energy application, we have to be very careful about the material. What kind of material we should choose? Those material should be easily available. It should be low cost. It should not be harmful. When you are handling those sources, it should not create any cause or problem. So those factors we should consider while choosing the material for green energy application. And then if we select a particular material, that material might be prominent candidate for green sources. So earlier, non-renewable sources, then we started to use renewable. Now we are focusing on direct green energy sources. So there is no harmful to the humankind or environment. Such sources are good for our society. Now in the search of such kind of material or energy sources, one of the application is photocatalysis. Before explaining you the meaning of photocatalysis, I want to tell you why photocatalysis is important. First of all, our earth has 70% of water. But 70% water, most of the water is covered by the sea. Now, when we talk about the water that comes from sea, has various mineral. We cannot use that water for drinking or for cleaning purpose, because various kind of minerals, salts can be found in those seawater. To process seawater, it's very expensive. So when we want to drink the water, we usually drink the water which comes from the river. When we are using the water for the factories, companies, those water also comes from the regular sources such as river, we might use the cleaning water again and again. There are several processes. But this seawater is not useful for us, not for drinking, not for any kind of cleaning purpose. So remaining 2.5% is water that can use for drinking and cleaning purpose. As you know, our population is increasing. Now we are getting enough water, present generation. But in future, if population increase, there will be shortage of water. So how to deal with this situation for the next generation? We have to find out solution for next generation or even for us. You might not know what will happen after 10 years. We should not sit, something will happen and we'll see. We have to find out some kind of solution for our next generation. So we should be careful while using this 2.5% of water. The number of people, the population increases, water will not increase. Water will not increase. So the problem for reusing the water will always come. There are many factories, companies, units that use the water for cleaning. And when they use the water for cleaning, that water consists of some kind of organic pollutant. Organic pollutant means it has some kind of organic material which is consists of carbon or hydrogen based material. Now, when the water which was clean water but used for cleaning purpose, it get contaminated. Contaminated means now there are some organic pollutant put or come into the water and it become contaminated. In our regular language, you can say it is a dirty water, unclear water. Now jobs come how to clean this water and reuse it. Remember, we are not talking about the drinking water. We are talking about the water which comes from the cleaning in the factory such as textile industry, pharmaceutical industry. They use lots of water and that water can be contaminated. It consists of various kind of organic species that we call as organic pollutant. So how to clean this water and make this water for reuse? If we successfully clean the contaminated water into the pure water or clean water and we can able to use that water again and again, that process require photocatalysis. Means it is one of the methods to clean the contaminated, impure, dirty water into clean water so that we can use it again and again. This is the importance of photocatalysis. When we will talk about the photocatalysis, during this talk you might hear various terms. What is photocatalysis? What is catalyst? What is photolysis? What is radical? What is organic pollutant? What is photon? What is energy? These terms I will frequently use for the lectures. So those whose background may be mechanical, electrical, or they are not belong to physics, chemistry, they might heard this term for the first time. Don't worry, I am going to explain you some of the basic term so that today you will understand what photocatalysis really means. So photocatalysis, catalyst, photolysis, together is photocatalysis, radical organic pollutant. I told you about the organic pollutant, energy, green energy, photon means light. So all kind of words will be comes while I talk about the photocatalysis. Terms photocatalysis comes from photolysis. What is photo? Photo means photon. Photo means photon. So we took this photo here. That photo means photon, means light energy, some kind of light, artificial light or natural light. So that photon, we just took the photo, and lysis means break down. You break down something, electrolysis. So where electricity is used to break down the material. Photolysis, you use photon, light, to break down the material. So this is the basic term, okay? Photolysis. Now you understand what is photolysis. Photolysis is the process that uses light energy to break down materials, okay? And when you break down the material, I told you contaminated water, it consists of organic pollutant. So if you want to break down those material, such kind of process is required. When we are dealing or doing the photolysis, it can be done in the presence of visible or UV light. Photon, light, okay? So we need some kind of light to do the photolysis. If you want to do electrolysis, you need some kind of electricity. Photolysis can be enhanced. Simply, when you put the light, photolysis starts. But if you want to enhance the performance, efficiency, you can add something, ozone or H2O2, hydrogen peroxide. So that process become faster and performance increase. Why? Because we want solution in quick time, we want solution in better way, it should be faster than earlier solutions. So that's why we add something so that this process can give a good result in a short time. Then this photolysis, in the photolysis, we are just using visible UV light, and sometimes we add some kind of ozone or hydrogen peroxide. Photocatalysis is the improved version of photolysis. Photolysis, light break down material. And now you are adding cata. What this cata means? Cata means catalyst. So photocatalysis, light energy with the help of catalyst. It's additive. Earlier we are not using additive in photolysis. Now we are using some kind of addition of material that is known as catalyst to improve the breakdown. Because yesterday I have shown you that CVD methods. So there was methane, C and H, methane and hydrogen, CH4. So carbon and hydrogen break down there, decompose, separate. Similarly, when you want to clean the water, organic pollutant has a certain species that is made up of carbon and hydrogen. So you want to break down that chain and clean the water. So when you want to break down, there is a chemical reaction. And if you want to enhance this process of breaking down the material, you need catalyst that assist. Like if you are running, somebody push you, you will run more faster. Because you have your own energy when you are walking or running. And if somebody push you, your running speed will be faster. Because you take the help of someone or somebody help you. In the same way, if we use the catalyst, this photolysis process enhance. So catalyst is a substance that increase the rate of reaction without being consumed. This term is very important. Without being consumed, okay? It break down the material. Like if I want to go until that door, somebody will push me until the door and he will come back again here. If next person come, he will again push. So without being consumed, okay, nothing will happen to him. that substance. So substance that called as catalyst help to increase the rate of reaction without being consumed. This photocatalysis is inspired by the nature or natural process we call synthesis, photosynthesis, photo, light, synthesis, making something. So in this photosynthesis, there is a light from sun. It comes on the leaves of tree, and then it can create O2. It can create O2. And this formation of oxygen in biology we call as photosynthesis. There is a chlorophyll which assists this photosynthesis process. Similar kind of concept is used in the photocatalysis, because in photocatalysis we are using photocatalyst. In photosynthesis there is a chlorophyll which help to create the oxygen. So photocatalysis can be done in the presence of light and water. Why light? We need photon, okay? That is one thing. Why water? Because we are dealing with the water. We want to clean the water. So photocatalyst can create strong oxidation agent and electronic hole to break down the organic matter to carbon dioxide and water. When photosynthesis occur, creation of oxygen, okay? When photocatalysis occurs with the help of light, what happens? You can create certain radical, okay, OH radical or electron. And that OH radical can react with organic pollutant, and then it can create H2O in the clean form and CO2. This is the basic principle of photocatalysis. I will explain you in more detail what photocatalysis, how photocatalysis occurs. And this photocatalysis is totally based on the photosynthesis. Here the chlorophyll can act as a catalyst, There is an oxidation and reduction process occurs. There are electron, there are hole. When you put the light on the any kind of material, on the photocatalyst, the electron excite, the charged particle excite, and they can make movement from valence band to conduction band. While they move from valence band to conduction band, electron usually move from valence band to conduction band. It creates the reduction and oxidation of a charges. So with the help of UV light we create in laboratory, but natural sun can provide UV light directly. When we do the photocatalysis in laboratory, we cannot use sunlight directly. We use UV light of the same wavelength, or we can use LED light also. So when we use UV light, electron can jump from valence band to conduction band, and reduction process can occur. On other side, this hole can participate in oxidation. So movement of electron. Why? Electron is moving because there is a light. You need certain kind of energy. I told you I want to go to the door, but myself, if I want to go, I am going very slowly. However, I want to go faster. So some kind of energy is required. Mechanical, kinetic, something, someone should push me, then I can move forward. Otherwise, I will sit here. So electron is sitting here. Once you give energy, it will go. So while going up, it can have a reduction of charges, and oxidation also. So this oxidation and reduction process occurs simultaneously, because once electron move, hole created, hole participate. So this is continuous process, continuous process. Light is coming on the semiconductor or photocatalysis. So with the help of light, oxidation and reduction process occur. And oxidation reduction process occurs means charge movement of charge particle. So charge particle should move fast to give the faster, better result and efficiency. So the efficiency of photocatalysis depend on how one can prevent this charge recombination. Charge recombination means this electron and hole, how they move faster. Now, you take one photocatalyst, okay? Any material, semiconductor material, two-dimensional based material. This is your photocatalyst material. Light pass, or we put the light on this surface of photocatalyst. Okay, this is the surface of. On the surface there are positive, negative charge. When we put the light, charge get excited. Both charge get excited. Then there is a oxygen. There is a oxygen. So oxygen react with this negative charge and it create O2 minus. Okay? Earlier we put the light on the photocatalyst, positive negative charge get excited, electron can react with the oxygen, it can create O2 minus. Then remaining hole, this is very important. Remaining hole, we have water also. So remaining hole can react with H2, and create OH radical. This OH radical name as hydroxy radical. So this hydroxy radical are the real component that decide the performance of photocatalyst. Once this hydroxy radical are created, there are bacteria or organic pollutant in the water. Now this OH radical are ready to react with this organic pollutant, organic molecule or bacteria. Then they react, okay? They react with this OH radical. Once OH radical and this organic pollutant react with each other, H2O and CO2 is created. So this way, finally the water become clean, and of course there is CO2. But the good thing about this technique, you don't need any electricity. You just need solar light. You have not used any kind of electricity. You don't need any kind of money. What you need only photocatalyst. That's it. Solar light is already available. So this way we can create H2O and CO2. This is only one light, one photon come and this thing happen. It happen in few seconds, femtosecond. And this is continuous process. That's why photocatalyst material can be intact during the photocatalysis process. So this is a continuous reaction. Charge go up, charge excited, electron go up, then positive charge react with oxygen, electron react with oxygen, and positive charge react with the water. They create hydroxy radical, and hydroxy radical can react with bacteria or organic pollutant, and this way you can create the H2O, that is water, and CO2. The main thing in the photocatalysis is creation of radical, break down the material. Photolysis, photocatalysis means break down the material. So organic pollutant react with this radical. If radical is created, your job is almost half done. Next part, this radical will react with organic pollutant, or this radical will kill organic pollutant, and you can get the clean water. So earlier, when we put some kind of organic pollutant in the water, the color is blue. It is methylene blue. Okay? So after certain time, you put the light and you check after 10 minutes, after 20 minutes, 30 minutes, 40 minutes, or 60 minutes, the color of the solution gets changed. So this shows the formation of clean water with the help of these photocatalysis, which create this hydroxy radical. So this is the basic thing, what happened during the photocatalysis. In short, I will explain you again. Photocatalysis, when you put the light on the photocatalyst, charge get excited. Okay, positive, negative. Negative electron charge react with the oxygen. Positive react with the H2O. Then it create OH radical. OH radical can react with the organic pollutant, and once they react, H2O and CO2 can be formed. I hope that you can understand this process of photocatalysis now. Why this photocatalysis is important, or what kind of advantage, benefit this photocatalysis method have? First is economic. What it need? Yes. Sorry, this one? No, it's clean water. Because, yeah, bacteria means, you say corona or organic pollutant. Organic pollutant, they are mostly made up from carbon, hydrogen, okay? So, they have strong bond, okay? If you break that bond, then they will separate. And once you separate, water will be clean. If they are not separate, okay? If they are not separate, water will remain as it is. Visually, you can see this in the photocatalysis. Like you put the light, you put such kind of bottle for 10 minutes, okay? Your solution color will be little bit lighter. Again, 10, 20 lighter. After 1 hour, 45 minutes, depending on what kind of photocatalyst you use, the time is also changed. First is economic, means it is a low cost methods. That's why it is preferred to use for the photocatalysis purpose. Efficient. Efficient means it gives quick result. Visually you can see it. Green technology, because as I told, no external source, no external support is required except photocatalytic material. So this is the 3 biggest advantages of photocatalysis process. I told you that we will use only light, okay? But it not only light, it consists of water also. It consists of organic pollutant in the liquid medium. So what factor, what are the parameters that affect this photocatalysis process? For example, this light has certain energy. If we increase energy, power or intensity, we cannot stand here, okay? This energy is not harmful to us, so we can stand. Or this laser is only used for with small energy, it cannot harm. But some of the laser can really harmful to your skin. So it depends. When you increase the intensity, the process of photocatalysis might spoil. So semiconductor concentration means the how much photocatalyst you are putting into the water. For example, if you took 3 milliliter, 4 milliliter of water, contaminated water, if you put 1 milliliter methyl orange, that is organic pollutant. Now, how much percent photocatalyst you will put? 5%, 10%, 20%. If you put more concentration, result will be fast. But more concentration is not good. It should be less, so that less material can give better performance for bigger water quantity. So concentration of semiconductor material, or let's say photocatalytic material, is important. We have to choose certain percentage. It may be 3%, 5%, or even 10%, but not 50%. That will be too big. Light intensity. Now, intensity of light. How much intensity? What kind of light source you are using? How much energy you are giving? Whether you are giving 100 milliwatt, 200, 500, 7 or 1 watt. That intensity can affect the result. Temperature. We are dealing with the water, so temperature is important. And pH also. pH can also decide the photocatalytic performance. So while doing this process, we need to consider these 4 parameters while deciding the performance of photocatalyst. Where are the application of this photocatalysis material? The application of photocatalysis material is in dye or textile industry, where unclean, contaminated water, which consists of various organic pollutant, is thrown out after using the water, or pharmaceutical waste water, or recalcitrant compound, means the compound which cannot break easily, hard compound. So even though the hard compound means, like I told you about the diamond and graphite. Graphite you can break it easily because bond is very loose. You need a small energy, you can break the pencil. Graphite is made up of carbon, but you cannot break diamond. You cannot break the diamond. Diamond bond is so strong, you cannot break it. That's why we call diamond as a hard material. Similarly, some organic molecules are very hard to break. Those organic pollutant can be break easily with the help of photocatalysis. Now I will move to the recent development. What kind of nanomaterial use for the photocatalysis? There are various research papers on the photocatalysis. This research on photocatalysis initially was started in 2000, around 2003. There were less than 1,000 papers. But now, in 2021 and 2024, this number might reach to more than 10,000. So you can see it was less than 1,000, even few hundred, and now it reached to more than 10,000. So number of researchers who are working on this topic is increasing. This term photocatalysis is derived or comes from the experiment done by Professor Fujishima of Tokyo University in 1967. He was working on TiO2, titanium oxide, and he wanted to split the water. As I told you that earlier electrolysis was there. Electrolysis, electricity and laces breakdown. Electrochemical, electrolysis, it need some kind of electricity. So he want to do the photocatalysis, and he found that it is possible to do the photocatalysis with the help of light, without using electricity. This is very important, without using electricity. And 1967, that is almost 60 years before, he was doing this research. The first major paper come in 1972 in the Nature. And in 1980s, researchers started to think to use titanium oxide for various purposes, for solar cell, for photocatalysis, but very few researchers was working. In 1992, technology to apply thin layer of TiO2 was developed in Japan. So it started in 1960, and you can see after 25th year, first commercial breakthrough come for photocatalysis. And in 1990, some of the companies started to make self-cleaning window. Now, what is self-cleaning window? So if you put the certain kind of coating, the moisture cannot stand on the windows. So those windows called as self-cleaning windows. In the winter, the temperature outside is cold, but inside is hot. When this difference in the temperature is there, sometimes you can find the water particle stay on the glass. So if you are using smart window, that water particle will not stay. So those kind of glass is called as smart windows. Smart windows. So this is the first kind of application, comes in 1990s. And after that, people started to work on photocatalysis by doping the metal or non-metal and visible light driven semiconductor. Semiconductor means some kind of oxide material, TiO2, SnO2, WO3, and doping metal, Ag, Au, or some non-metal, zinc, and so on. Heterojunction semiconductor. Initially, they work individually, metal or semiconductor. Later on, heterojunction, binary, like you can use metal and combine metal with some semiconductor. For example, TiO2, Au, Ag, SnO2. So make binary composite material, heterojunction material, or even oxide-oxide. So those kind of heterostructure can be studied for photocatalysis. And then SPR, enhanced photocatalysis. You can make or add the metal particle which can have surface plasma resonance. For example, Au. If you want to enhance the performance, like we started with photolysis and we add catalyst, performance increase. But still, if you want to increase the performance of photocatalyst itself, what are the parameters that can really help to enhance the efficiency of photocatalysis? First of all, what kind of nanostructure you are preparing? Whether they are particle, they are rod, they are metal, they are sheets, what kind of particles, nanostructure you are preparing, and whether it is useful for the photocatalysis. That is one of the factors. Extension or absorption in the visible region. So we are using visible light, okay, sunlight. So that the nanostructure should be very sensitive to visible range. So it can extend that visible band. If nanostructure cannot give the response, then we will not see the photocatalysis, enhanced photocatalysis. So while choosing the material, make sure that that material should be very sensitive in the absorption region within that visible range. And titanium oxide was researched from 1967 to till date. But last 12 to 15 years, especially after the graphene discovery and Nobel Prize, researchers started to work on two-dimensional structure. And that two-dimensional structure is non-titanium base. Titanium oxide has some disadvantages. So there are three factors. What kind of nanostructure you are preparing, whether they are sensitive to the visible range. Third, that must be non-titanium based material, because titanium has some kind of disadvantage. The efficiency is limited if you use titanium oxide. That's why replacement for the titanium is going on. Like solar cell. Till today we are using silicon, but people are started to find alternative to silicon, low cost material. So this is the progress made in the field of photocatalysis so far. Metal, these are the noble metal, Ag, Au, platinum, palladium, and these are metal iron, zinc, aluminum, copper, and so on. And other oxide like zinc oxide, TiO2, SnO2, these are various combination of N-type and P-type metal oxide that can combine with this metal or metal ion. So there were many papers which consist of, for example, CO2 SN or Fe2O3 Au Ag, and there are several combinations. They try for photocatalysis. But still today, the efficiency is not good. That's why research is still underway. And since this combination of metal oxide or metal oxide semiconductor with simply metal not good, then they shipped this metal oxide with some kind of carbon-based material. For example, CNT, reduced graphene oxide, or multi-wall carbon nanotube. Metal oxide, carbon-based material. Metal oxide, metal. So binary composite, you will find several papers. Last 3-4 years, instead of this binary, the ternary composite can be prepared for photocatalysis. Why? Because metal oxide, especially TiO2 like metal, has some difficulty in the rapid electron hole recombination. So that electron hole recombination is the disadvantages and insufficient light absorption range. Okay? Up to certain it can give the response, but it cannot extend its absorption band. So that's why, due to the less rapid electron hole recombination rate and insufficient light absorption range, some metal oxide is not enough for photocatalysis. To overcome this problem, as I explained in the last slide, metal can be added to faster this electron hole recombination, or certain kind of doping with rare metal or iron metal can be added, and then you can deposit, you can create the nanostructure which is consist of P-N type of semiconductor. So what basically you did to overcome with this problem, you add metal, but still the efficiency is not up to the mark. We still want to improve. So another thought come, we can couple this semiconductor metal composite with carbon nanomaterial. Earlier, metal oxide, then there is metal oxide and metal, or metal oxide and carbon, and now it's metal, semiconductor, and third is carbon nanomaterial. Carbon nanomaterial or two-dimensional material. So, the idea of using the ternary composite may overcome with these disadvantages. So, in this way, we can enhance this light absorption ability and separation of charge, or we can increase the electron hole recombination rate. So, in our laboratory, we have also worked on certain kind of ternary composite. Yesterday, I have shown you one of the slide about the synthesis of making indium selenide nanocube. We are basically working on two-dimensional materials in our laboratory. So, two-dimensional materials are very interesting material because of its property. Two-dimensional, day before yesterday, we have seen the type of nanomaterial, okay? So if you remember, two-dimensional material is a sheet-like material. So those material has large surface area and higher electron mobility and optical transparency. So these are the parameters which we consider should be important when we took them for the photocatalysis. Then oxide material, although TiO2 has this one, but other oxide material can be tried with this two-dimensional material like Fe2O3, SnO2, WO3. And those material should be having low cost, small size. That is the crucial. And in addition to two-dimensional material and metal oxide, this metal is also added and make two-dimensional semiconductor and metal composite. So metal enhance photocatalysis. The role of metal is the same. As I told you, I want to move to the door, somebody should push me. So this metal nanoparticle push these charges quickly and enhance the recombination rate. Each component has certain role. So individual role, if you mix them together, make ternary composite, then end result is good. So to make the nanocomposite with the help of two-dimensional or based on the two-dimensional material, we can create the composite material of two-dimensional carbon nanomaterials and metal. Together, we can make two-dimensional nanocomposite with different surface morphology. It may be nanocube, spherical, nanorods, or simply various kind of hexagonal shape. And then tested for photocatalysis. We are using laser ablation, and we have created this kind of structure in our laboratory. So this is nanocube, this is nanoparticle, quantum dot, these are nanorod, nanorope, like this is octahedral structure. So all these structures is created in our laboratory. So those are structures, like this is tin oxide structure. These are like bismuth sulfide. These are indium selenide two-dimensional materials. And we have also created Ag nanocube. Similar to indium selenide, we have also created Ag nanocube. So various surface morphology can be possible to create by using the laser ablation. To create this material, you just need 20 minutes or 1 hour. Within 20 minutes or 1 hour, this process can be created. Even laser ablation is also eco-friendly technique, similar to photocatalysis. You just put something into the water and you get the nanoparticle within few minutes. So this is the one of the nanoparticle we have created using the laser ablation. I am not going to tell detail. I just want to show you the surface morphology. Our aim is to create the ternary composite. So ternary composite can be created using the hydrothermal process. Initially, we create two-dimensional material using laser ablation. And then metal like AgAu also created by laser ablation. Then we put oxide material in this hydrothermal autoclave, and after hydrothermal we can perform photocatalysis. Now first example is this. This slide I have shown you yesterday and you already know about this, so I am not going to explain this slide again, but you can just understand that we started with the bulk material which has the size of 2 micrometer. Okay, this is 1 micrometer, okay, and this is sheet-like structure. Okay, sheet like one paper on another. There are number of sheets, 1, 2, 3, 4. So this sheet-like structure is converted when we change the time from 5 minutes to 20 minutes, and we can get the nanocube. This is the same slide which I have shown you yesterday to show you the difference before and after laser ablation, transformation of thin sheet into the nanocube. This is the same thing. And indium selenide, which was created by laser ablation, was mixed with the zinc oxide and Au. Here Au was also created separately by laser ablation, zinc oxide by sol-gel method. So individual nanostructure was created by different technique. They mix together and put into the hydrothermal autoclave, and after hydrothermal we can create the ternary composite. This way, hydrothermal you can create the ternary composite and put for the photocatalysis like this. You put xenon lamp. For this research we have used the xenon lamp, and this is the sample. I have shown you the one of the slide where we are using methylene blue. The solution color is blue. After a certain time it becomes white. So this is the images of ternary composite. Now look at the performance. Here this is first, that is A is indium selenide nanocube. B figure is indium selenide Au, okay, and C figure is ternary composite. So performance wise, if you look at individual nanocube cannot show better performance, then we add Au, little improve, but after making ternary composite, look at the efficiency. Within a certain time, it can show better photocatalysis performance. So this shows that if we make the combination of semiconductor oxide material, two-dimensional material, and metal oxide, metal particle, metal nanoparticle. So combination of metal nanoparticle, oxide material, two-dimensional material can give better performance. What is the role of Ag here? So Ag can transform the electron to the zinc oxide, and then zinc oxide to indium selenide, and then indium selenide can help to create the photocatalysis process. So this process of transportation happen quickly with the help of this metal. If there is no, then this process will slow down. But with the help of this metal oxide, the process can occur quickly and you can see the result. So this suggests that both metal, nanoparticle and oxide are equally important when we make the ternary composite based on two-dimensional material. Another combination, it was binary, not ternary, but I just want to show this is the interesting result. We started with WS2. We started with WS2 and we create WO3 minus X. In the laser ablation itself, solar energy use, we are using the light laser energy. So laser energy break this W and S2 and O come from water and it can create WO3. That's why this result is interesting. Another also, SNO. We took SNO and water is the solvent. Then SNO is transformed into SNO2. So both make separately, then we just add them, do the probe sonication for photocatalysis. These are the result. Initially, you can see petal-like morphology, and these are octahedron SNO2, and on octahedron SNO2, WO3 can be seen. This is the characterization. I will not go into the detail because of time, but it confirms the formation of these binary structures. Binary structure can give better performance, although it is not 98, 95%, but if we add some metal in it, so this efficiency will definitely increase. However, it gives an idea that we can use SNO2, we can use WO3 while making the ternary composite. So after this, we are trying various combination with the WO3 material. Sometimes our result is not good, but it gives a direction that certain material are useful. They can highly responsive to the UV light. Then such kind of combination is good. We can add either metal nanoparticle or other two-dimensional material and make a ternary composite, and that ternary composite might be shows a better photocatalytic behavior. Now the last part for today's talk is water splitting for hydrogen production. First slide, I have explained you that why we need photocatalysis. Now, why we need hydrogen production? What is the requirement? Why we want to do the research in the field of hydrogen production? Everyone is looking for clean solution, okay? Green energy. So, clean energy source. Everyone is looking for, there is a demand for green energy. That's why this is one of the maybe methods that can be used to create green energy. Now, energy security. We have limited energy sources, fossil sources. So we must, fossil sources means even your petrol, gasoline are limited. After certain year, it will. Of course, we are using electrical vehicle, okay? But still, it need electricity. And if you need electricity, again, CO2 is created. So it is harmful to the environment. So we are looking for green energy sources. So direction or finger goes towards the water splitting. Economic growth. Like our economy increases, the price of this fuel is increases, the storage of this regular non-conventional energy sources will definitely decrease with the time, but their price will increase. So to overcome with this problem, we should find out alternate sources. And this is efficient. It can show the efficiency about 75%. Portable, like when you want to use the or you want to create the hydrogen, it can create with a portable instrument that you can easily carry. So it needs less space. That's why such kind of maybe methods that create hydrogen production is useful, and one can consider water splitting for the hydrogen production towards the search of green energy. Now, when we think about hydrogen production, what are the measures we must consider when we are searching for the hydrogen production? We have to build the infrastructure, because at present there is no infrastructure. And safety concern is also a problem that we are dealing with. We are not sure how much energy sources we have at this moment and when it will finish. It may finish in next 20 years or 30. I'm talking about the fossil energy sources, the non-conventional, non-renewable sources. So the security will be the concern for this kind of production. We have to look for the hydrogen production, because security is related with the energy. If you have energy, you can do many things. So in future, energy will be one of the crises that humankind is going to face. And today we say that we are using renewable sources like wind energy, solar energy. You can see many everywhere. But in reality, the contribution of these renewable sources are not much. If you go to the power station, like how this electricity is generated, those electricity is coming from non-conventional sources where CO2 is created. So the contribution of these renewable energy sources is less, very less. Most of the power is coming from the fossil sources or natural gas, and those can create CO2 also. So the solution for this kind of problem that we are facing or we will face in the future is going toward the water splitting. And water splitting application can be used in various fields like industry, transportation, building, and powers, or we can store this hydrogen for long time. So you can store and use later on also. That's why this hydrogen production is important. And once we succeed in this hydrogen production, then it can be used in various industries or various applications. Now, we want to create hydrogen production. Why water? Why only water? Because water is widely available. Of course, water is made up of H2O, hydrogen, oxygen. Since water consists of hydrogen, oxygen, and we are looking for hydrogen, we will choose hydrogen. We are not interested in oxygen. Okay, so water is chosen because water consists of hydrogen, and our target is to create the hydrogen. So water splitting is the process in which water is splitted into hydrogen and oxygen. Split. Same process. Like I told you, organic pollutant, break. Break is another word is split. Decompose. Almost similar word. They separated. So 70% of water is made up. Now, here, 70% for what? Including seawater. Hydrogen production can be gain much more interest as oil, like gas. And it is other non-renewable fuel become increasingly depleted and expensive. Non-renewable because gasoline and other sources will be expensive in future. So hydrogen is the source of energy that might be relatively cheap as compared to these non-renewable sources. And it can affect the economy also. So water splitting can reduce the emission of greenhouse gases. So CO2 emission can be reduced. If you are using gasoline, diesel, petrol, then CO2 is created and environment is harmful. So it can reduce greenhouse effect also. To break down this hydrogen and oxygen, there are various processes, various methods you can break down this. Electrolysis, photolysis, okay? Electrolysis, photoelectrochemical water splitting, photon, electric, chemical, chemistry, photocatalytic water splitting, radiolysis, photobiological water splitting, thermal decomposition, nuclear thermal chemical production. Various technique is there. Out of this technique, only photoelectrochemical water splitting is more promising technique. But why photoelectrochemical technique for the hydrogen production? Because based on the solar energy, which is a continuous source of energy, water is also a renewable resource. Like sun, we have also water. So water is available in large quantity. That's why when I told you, you prepare nanostructure, it should be low cost, easily available. Similarly, when you think about water splitting or hydrogen generation, the basic material, the raw material should be low cost and easily available. So water is easily available and environment safe with no byproduct. Therefore, when we use this photoelectrochemical technique with the help of water, it cannot create any kind of byproduct since the process occurs within the water. It may use on both large and small scale. So as I told, like small hydrogen production is possible. If you have this photoelectrochemical cell, you can make the hydrogen production quickly in a small space. And also you can make on larger scale. Now, what is photoelectrochemical water splitting? In the beginning, I explained you, photo means photon, okay, light, you understand. Electro, something related to electricity, okay. It consists of some kind of energy that comes through the electricity. Chemical, it consists of certain chemical. So, photoelectrochemical water splitting. Photoelectrochemical water splitting is decomposition based on conversion of light energy into electricity within a cell involving two electrodes. Okay? These are two electrodes, this one and this one. Immersed in aqueous electrolyte. So this solution is aqueous electrolyte. That is the water. Okay? We call as electrolyte. Of which at least one of made up of semiconductor exposed to the light. So one is made up of semiconductor and that is exposed to the light, okay, exposed to the light and able to absorb the light. In the photocatalysis, I told you that if you are making nanostructure, make sure that it should be sensitive to the light. So here, if you are looking for the good material, that material should absorb the light quickly. This electricity is then used for water electrolysis. Like when this light pass the charge excite. Charge excite means movement of charge. So this charge initiated by this light, okay? The positive negative charge is excited by this light. So this way, there is a valence band, there is a conduction band, there are two electrode working counter electrode. So basically, how the process occurs, it is almost same like photocatalysis. Similar kind of oxidation reduction process occur. Electron can move from valence to conduction band, attract toward the electrode with the help of this light. In electrolysis, there is no light. In photoelectrochemical, there is a light. In simple electrochemical, there is no light. Or electrolysis, there is no light. But this light excites this electron, and that's why this technique is called photoelectrochemical. So charge excited with the help of light, and then it can transform, okay? It can move, it can transport to the another electrode. So the movement of this electron is initiated by the light. And since this process is initiated by the light, we called it as a photoelectrochemical. This is the pure chemical reaction, oxidation and reduction. So I will not tell you the detail. Most of you is not from chemistry. Performance of these PEC cell, PEC photoelectrochemical cell. Excitation of electron in photoelectron. So how this electron is excited, that decides the performance. Separation of charge carrier, how these charge carrier are separated, okay? Positive, negative charge carrier. Electrode process and related charge transfer, okay? How electron jump from one electrode to another. And this way, you can get the good performance. Generation of PVE voltage required for water splitting. So when this charge move, a certain voltage is required to initiate the water splitting. Once this voltage is acquired, the water gets split. H2O, hydrogen and oxygen get split, and there are bubble started to come out from the solution, and that bubble nothing but the hydrogen. The factors that affect earlier in case of photocatalysis, if you remember, semiconductor, concentration of semiconductor, light intensity, pH. Here, size, shape of nanocluster, what kind of material you have used, electrolyte temperature, solution temperature, pH, particle size and defect, okay? So here is also size of nanocluster, here is also size and shape of what kind of electrode you have used. One of the electrode should be made up of semiconductor or other type of material. If it consists of a certain particle size or defect, it will affect the photoelectrochemical process. Then band gap energy, also important. How much band gap energy? Because you are moving the charge carrier. And intensity of light, again same thing. So water splitting and photocatalysis are complementary processes. These processes are almost same, only the end result is different. In case of photocatalysis, our aim is to clean the water. Here our aim is to create the hydrogen, okay? So both application different, otherwise process are almost same. How we can increase the process of water splitting? Maybe you can have some kind of ion implantation on the electron, or use some kind of ion irradiation, or some bilayer system electrode, you can replace, you can use another bilayer on the electrode or some kind of dye sensitization you can use to improve the performance of hydrogen water splitting. What are the future challenge? So future challenge is to develop the efficient material or photoelectrode. In case of photoelectrode, you need electrode that is made up of either semiconductor or some kind of material. So those electrode material, that is photoelectrode. Why we call photoelectrode? Because it is sensitive to the light. That's why we are calling it as a photoelectrode. So that photoelectrode material should be very sensitive to the light. Optimization of synthesis route on large scale production. So when we are making this photoelectrode, it should be ready to make on larger scale. Integration of monolithic devices and single cell into two-dimensional array or grid for mass production of hydrogen. So when we succeed to get the hydrogen production, the challenge will be mass production. Remember, large production is different and mass production is different. Okay, mass means huge production. Large means large area. Okay, small means 1 centimeter by 1 centimeter. Large means 6 inch, 1 feet, 2 feet, 1 meter. And mass means bigger than 1 meter. Okay, large, giant, huge. And finally, evaluation of safety standard. So here hydrogen is evaluated. So when we are using the semiconductor material for electrode, that is photoelectrode, that should not create any byproduct or harmful substance during the water splitting. So those are the challenges in future. So we have to deal with those challenges while creating the future hydrogen production. So with this, I will stop here. Today I cover two topics. One was photocatalysis. I show you some of the real example, and at the end I cover hydrogen production. However, I have not shown you the example. There are various kind of material, mostly semiconductor material, are used for water splitting, because water splitting and photocatalysis are almost same or similar kind of processes. So now it is almost 10:55 or so. We can use few minutes for question if you have. Thank you. Questions? Any question on photocatalysis, hydrogen production? Yes?
In India process, we produce HO in a large amount, but there are some losses. We cannot store properly. And,
You means the evaluation of hydrogen cannot be stored. Yeah, that is one of the problem when you combine, your cell, how to extract the hydrogen, and loss of hydrogen should not be there because it is in the gas. So that is one of the challenge you have to deal. It depends on how your design is made, so that when hydrogen will be created, it should come out with higher production, and transportation loss should be less. So that is the question we need to answer, but the answer lies in the design. You should think about the design to extract how much hydrogen we can extract. Now, how you are collecting the hydrogen? By tube, how you collect the hydrogen? No. When your water splitting experiment is going on, okay, there is a hydrogen production. And your question is, you can...
There are some losses of hydrogen. So how can we overcome this problem?
So why your hydrogen losses is happening? Because of the design? Or where is the loss? Where it goes? From the solution, when it comes, you cannot get the hydrogen. Where that loss goes? In the design. So that's why I told you that when hydrogen is created, definitely there will be some loss. We cannot get 100%. But to increase the efficiency, it is our design, So that design, the minimum path should be there. Once hydrogen created, and this is our, collection. So that distance should be very small, so that it can, collect the hydrogen. You have to work on design, I think. Yes.
Sir, in the last slide, you told about photo
This one?
No,
Future challenge? Sorry. Okay, just a moment. This one? Yeah.
You told about these two electrode systems. You said
One should be.
one is exposed to a light.
Because you will have one electrode. One electrode should be metal, because you are doing electrolytic process. So this voltage you will apply. So one should be like graphite or carbon or metal base, so that this process can be fast. And one can be semiconductor, because you are using the light. So when you use the light, we are in the search for photosensitive material. If this electrode is photosensitive, then process of production of hydrogen will be very fast. So that's why we are looking for some kind of photosensitive electrode.
So how can we distinguish between a counter electrode and working electrode in this
So usually we fix one, counter electrode, and this working electrode may be chances that we can replace. This is optimization, which one is good, because we are dealing with the light, okay? So traditionally you can use two electrodes, steel, platinum, this one, okay? But since, like in photocatalysis, I told you we are using the light. And why we are using the light? Because light is the main component here to create the hydrogen. So if this electrode is photosensitive, then the process of splitting will be very fast. That's why we are looking for certain electrode material that can show better water splitting performance. Normally you can use, usually here platinum they use as a counter working. It is in your hand which you use. What kind of electrode you have used? Which working electrode you have used in your experiment? Nickel. And counter? Platinum. So both are metal to metal, right? Have you tried other beside nickel? No. Why we are trying this? Because remember, nickel, platinum, they are expensive. As in the laboratory, we are the one person. We will use only 1 centimeter by 1 centimeter or 2 centimeters for us. But when hydrogen production will be in the market, we want cheap and low cost material, okay? This is not really taking into, but in future, when you will make the cell, that cell one is platinum for sure, okay? But if you use nickel also, the price will be high. The price should not very high as compared to the gasoline or petrol. So that's why whether we can replace this working electrode with some kind of semiconductor material so that the cost of this device will be less. Okay. It's perfectly 11. Is there any question? Okay. Thank you. Thank you. I will stop here and again I will see you in the afternoon for another class. Thank you very much.